In this question, it is given 3 blocks A, B, C having equal mass small m, and system is placed over this smooth horizontal surface. Coefficient of friction between block A and B and C is mu. We need to calculate maximum value of mass of block D so that blocks A, B, C move without slipping over each other, and we are given these 4 options. In this question, this line is important. The blocks A, B and C move without slipping over each other. It means the system of the blocks A, B, C moving together. That means there is no slipping between A, B and B, C. If system is moving together, that means the system should have the common acceleration. So common acceleration should be small a, rightward direction. So let us assume this acceleration is small a, and system is moving together. That means the nature of the friction between the surface of A and B, B and C should be static in nature. Block A and D are connected together with the light string. It means the magnitude of acceleration of the block A and block D should be same. So block D should move in the downward direction with the same acceleration small a. Now let us consider the free body diagrams. First consider block D. Mass capital M, that means weight will act in the downward direction, capital mg. Okay. String is light, that means tension in the string should be same. Tension at this point should act in the upward direction, and tension at this point connecting block A should be in the rightward direction. Okay. Now we can write the equation of motion of the block D. This is equal to capital Mg minus T, that is equal to capital M multiplied by small a. Okay. Let us make this equation number 1. Now consider the free body diagram of block C first. This block is moving in the rightward direction. Friction should be responsible for the motion of this block. So friction force on this block should act in the forward direction. So let us write this friction is F1, and we are interested to calculate the maximum possible value of the mass of block D. That means the friction between the blocks should be considered as maximum. Maximum friction force means limiting friction. So let us write this F1 max. Okay. Now consider free body diagram of block B. This is block B. Friction on the top surface should act in the leftward direction because friction at the same contact surface always occur in pair. So this is F1 max. So this will also be F1 max, but in the leftward direction. This block is also moving the rightward direction. Friction should responsible for motion of the block in the rightward direction. So this friction should be equal to F2 max. F2 max, why? Because we have considered the maximum mass of the block D. So maximum value of the friction at this surface also. Okay. Now consider block A. This is block A. The friction on the top surface in the backward direction should be in the backward direction. So this is F2 max. Okay. Tension will act in the forward direction, capital T, and this is block A, and system is moving with the common acceleration. So acceleration here is small a. Now let us consider the maximum possible value of the friction force, limiting friction. Limiting friction force should be equal to mu multiplied by n. So let us write n1, and we know this n1 is equal to small mg. Okay, because there is no motion of the block in the back upward direction. So this is n1 equal to small mg. So this value should be equal to mu multiplied by small mg. Okay, so this should also be mu multiplied by small mg, and like friction, normal reaction also occur in pair. So this is n1. N1 we know this is equal to small mg, and this is n2. Let us call this n2, and mass is small m. So weight should also be mg. So N2 is equal to mg plus mg, that is equal to 2 mg. It means friction here should be equal to 2 multiplied by mu multiplied by mg. Okay. So acceleration of this block, that means maximum possible acceleration of this block C should be equal to mu mg divided by m. We can write A1 max, that should be equal to mu mg divided by small m will get cancelled. So this will be equal to mu multiplied by g, and here also we can say A2 max should also be equal to 2 mu mg minus mu mg divided by small m. That means this is also equal to mu g. It means this acceleration should be equal to mu multiplied by g. So this should be equal to mu multiplied by g. Now we can write the equation of motion of this block A. This equation of motion should be equal to T minus 2 multiplied by mu multiplied by mg, that is equal to m multiplied by A, and we know A is equal to mu multiplied by g. Okay, this is equation number 2. Now we can solve equation number 1 and 2. We can add to eliminate capital T. So if we add equation number 1 and 2, the equation will become capital mg. This is capital mg, right? T and T will get cancelled, and here is minus 2 multiplied by mu mg. That should be equal to mu multiplied by capital mg, right, from this equation, and this is also plus mu multiplied by small mg. Okay. Now we can rearrange this equation. If we rearrange this equation, we will get the value of capital M. So here we can rearrange, we can write capital M in bracket 1 minus mu, g will get cancelled, and in the right hand side we will have 3 multiplied by mu multiplied by m. Okay, that means capital M should be equal to 3 mu multiplied by m divided by 1 minus mu. This is the maximum possible value of mass of block D, and it means option D should be correct. This is the correct option.